Today, we are going to take a look at one of the most familiar patterns in all of math, Pascal's triangle, and show you something absolutely extraordinary that's been hiding there in plain sight. Let's see what happens when we look at it in a way you've probably never seen before. So, most of us remember this from math class, right? Pascal's triangle. It's elegant, it's simple, and it's all generated by just one straightforward rule. Each number is the sum of the two numbers directly above it. 1 plus 1 is 2, 1 plus 2 is 3, and you just keep going, creating this beautiful, symmetrical structure.
But here's where it gets really interesting. What happens if we just flip that one fundamental rule? Instead of adding the numbers, what if we take their algebraic difference? I know, it sounds like such a simple change, but you'll see it opens up a completely new mathematical universe.
Yeah, that one little pivot reveals what the source material calls a digital antimatter world, a perfect hidden mirror image to Pascal's triangle that, believe it or not, has been there all along, just waiting for someone to find it. And building it is just as simple as the original. You start with 1, then a row with a 1 and a 1. But for the next row, you subtract. 1 minus 1 gives you 0. Then for the row after that, you do it again. 1 minus 0 is 1, and 0 minus 1 is negative 1. See, we're just mirroring the creation process, but with a minus instead of a plus.
And this is what you get. It's called the Perez hourglass. The top half, the northern hemisphere, well, that's just our classic Pascal's triangle built on addition. But the bottom part, the southern hemisphere, that's its antimatter twin, built on subtraction. And together they form this incredible, perfectly symmetrical hourglass shape.
Now, this isn't just some pretty pattern. According to the research, this new structure is governed by a whole set of really strange and elegant mathematical rules, and they reveal some seriously surprising connections. Let's dive into what those are.
So the source paper points out a few mind-blowing principles here. For one, the famous Fibonacci sequence just appears out of nowhere in the diagonals. And as we're about to see, every single row in this new antimatter hemisphere has this perfect, constant balance. These properties create some connections you would just never expect.
Okay, first up, that Fibonacci connection. If you sum up the diagonals in the southern hemisphere, just like you can in the original triangle, the Fibonacci sequence just pops right out. 1, 1, 2, 3, 5, 8, 13. It's an absolutely unexpected and, honestly, profound link between two of math's greatest hits. And remember that perfect balance I mentioned? Well, here it is. It's the number 2. If you add up all the numbers in any given row of the southern or antimatter hemisphere, the sum is always 2. No exceptions. It's this perfect, constant balance hidden inside all that growing complexity. So here's the crucial point. This isn't just a mathematical curiosity. The author claims this pattern has huge implications, starting with one of the biggest challenges in modern tech, quantum computing.
You know, the single biggest problem holding back quantum computing is this thing called decoherence. Basically, quantum bits, or qubits, are incredibly fragile. They lose their information almost instantly because of noise from the environment. The source has a great analogy for it. It's like a perfect radio signal that just dissolves into static. And that fragility is exactly what makes building a stable, large-scale quantum computer so unbelievably hard.
Now for the incredible claim. The idea here is that the Perez hourglass isn't just a pattern, it's a natural blueprint, a pre-made, mathematically perfect solution for shielding those fragile qubits from decoherence. The very geometry of the hourglass is being proposed as a powerful quantum error-correcting code.
Let's break down what those numbers really mean. The proposed code would be crazy efficient. In theory, you could bundle just under 1,600 of today's fragile physical qubits to create one single ultra-stable logical qubit. But here's the best part. It would be so resilient that it could self-correct up to 71 errors at the same time. I mean, that would be a massive leap forward for the entire field.
And this is kind of what it might look like. This visualization shows how physical qubits could be arranged in a 3D lattice that follows that same hourglass geometry. According to the theory, a structure like this would just naturally drain errors away from the logical qubit at the center, giving it an insane level of protection.
But wait, there's more. The applications don't just stop with quantum computing. The source paper proposes another revolutionary use for the hourglass's unique properties, and this time it's in the world of artificial intelligence and data storage.
It's called Perez hourglass associative memory,
or PHAM for short. Now, associative memory is kind of like our human memory, where you can remember a whole scene from just a small detail. PHAM is claiming to be a totally new class of this memory that can store and retrieve info with perfect 100% accuracy, which is unlike anything we have today.
So how does it really stack up against what we have now? Well, this comparison table says it all. Existing models like hot field networks have very limited capacity, and when you retrieve data, it can be a bit fuzzy. PAM, on the other hand, claims a theoretically infinite capacity, instantaneous and exact retrieval, and get this, 0 data collisions. It's a total paradigm shift, moving away from a foundation in statistics to one based on pure number theory.
And this isn't just theory. In computational tests, researchers generated over 2.5 billion unique data addresses from this pattern, and they found the collision rate was basically 0, less than 3 in a billion. This thing is effectively a blueprint for billions upon billions of unique, error-free addresses for storing data on a massive scale.
So what does this all add up to? The source presents this discovery not just as a new tool, but as the key to a whole new era of computation, all derived from a pattern hidden in a 350-year-old triangle.
And this is really the core idea, a single, unified structure that brings together Pascal's triangle, the Fibonacci sequence, and the golden ratio. The claim is that this fundamental geometry of numbers gives us a direct blueprint for building the next generation of fault-tolerant quantum computers and perfect recall artificial intelligence.
To end, I just want to leave you with this really powerful quote from the paper. It perfectly captures just how radical this idea is, that the very fabric of mathematics, like the sand in an hourglass, isn't just a static pattern. It actually holds the code for active, powerful computation.